concepts on censoring and truncation. Not too much, but just to give you the necessary elements over there. And I'm going to start with an example from a disability insurance product. So what I'm visualizing here is the onset of periods of disability for policyholders. And this kind of concept or this kind of tooling, we call it a Lexis diagram. It's a popular tool in demography, but also in certain actuarial modeling problems. And what we see here is that each line represents the onset of a period of disability for an insurance policyholder. Yeah, and that goes over time. And if you look at the picture here for insured number 1, well, what is typical in such disability insurance products, think about a disability insurance product for a self-employed person, you need to choose a certain waiting period in this contract. And this waiting period acts like a deductible. And that means you're going to specify whether, in case you're not able to work, whether you will be able to cover the first week, the first 2 weeks, the first 4 weeks, etc., whether you will be able to cover or to bridge that period with your own savings, or whether the disability insurance product should already start paying you a replacement income in case your disability is longer than 1 week, longer than 2 weeks, longer than 4 weeks. So you need to decide yourself, how many weeks can I bridge with my own savings, with my own with the money on my savings account, let's say. And I guess it's obvious that the longer this waiting period, the cheaper the insurance contract becomes, because it means that you can bridge this that you can bridge a longer waiting period with your own savings. So what we see here is that the waiting period is indicated with a dashed line, and that we then let the periods of disability for the insurance policyholder, we let it start then after this waiting period. And it runs until my policyholder recovers, so is able to get back to work, or dies, or cancels the contract, or if the observation period ends. So if we're at the present moment, then we also see that our observation of this period, this time spent in disability, our observation of that is stopped. So in this first example, we see that we observe the insured policyholder from the onset of the disability contract to the settlement of the contract, if you want, or to the recovery of our client. In the second example, we see that this is an insured whose disability is not exceeding the waiting period. So that means this insured is very lucky and can get back to work before the end of this waiting period. And in the case of insured 3, we see that he or she is still disabled at the present moment. And the present moment is indicated here with this broken line. So that's the end of my observation period. That's the now. It's the now, it's the present moment. And the only thing I can say as an insurance company is, oh, I have this client. He or she is still in the state of disability. So I know that her time spent in disability is going to be larger than what I observed so far, but I don't know how much longer. Yeah, how much larger or how much longer, because I cannot see in the future. I will observe this possible recovery. I will only see that in the future. And that is an example of what we call in statistics right censoring. So we see part of the observation, and we know that the real observation we're actually interested in is going to take a value that is larger than what we observed so far, but we don't know how much longer or how much larger. Yeah? And that's an example in statistics of right censoring. What is then an example of left truncation? Well, that's the whole idea of the waiting period. Because in fact, as an insurance company, we would not see those policyholders in our records, in our databases, who have a time spent in disability, which is shorter which is not exceeding the waiting period in the contract. So we only are interested here in those observations which overshoot the waiting period, because those are the contracts for which we will have to pay a replacement income. Yeah. So you see here an example of left truncation and of right censoring. And that's what I want to make a bit more formal now with some notation or some concepts. Yeah. So you see it summarized over here. We have left truncation, the insureds which are disabled during the waiting period. They are in principle not observed by the insurer. With right censoring, the insureds which have not yet reached recovery or death by the end of the observation period, their duration of disability will be above a certain value, but we don't know by how much. Now, there's a big literature on these concepts in statistics, typically discussed in a course on survival analysis. So we don't need all this machinery, but we do need to understand the basics. Because also later on, if we're going to estimate models on actual data, then we should be able to take this truncation and censoring into account in the appropriate way. Yeah. I've got another example, which is perhaps a bit more difficult to explain for me. This is coming from claims reserving. So what you see here is the occurrence of claims or accidents or insured events here over time. And after an accident occurred, the client will notify the insurance company about this accident that happened. Yeah. And if the corresponding claim is accepted by the insurance company, then some payments will follow until the claim finally closes or settles, indicated here with a black triangle. Yeah. If you look at the censoring, if you look at the amount that you pay on this claim. So what you pay on this claim, it would be the sum of the euros that correspond to the white squares, because these are the claim payments. So if you look, for instance, at this claim, this is a claim which is on its way, right? It has been reported. We already did 2 payments, but at the present moment, the claim is not settled yet, because this black triangle is taking place beyond the dashed line, beyond the present moment. So here you could say that the total amount we paid on this claim is right censored, because we know that in the end we're going to have to pay more on this claim, but we don't know how much more. Yeah, so this is an example of right censoring. What we paid so far on this open claim, this claim that has not settled yet, that amount is right censored at the present moment. So that would be an example of right censoring. Another example of right censoring would be the time that elapses between the reporting of the claim, the black circle, and the closing of the claim, the black triangle. That time is something that the insurance company will also monitor. How much time do we need to settle, to develop these claims? And what you see here is, for a claim that is on its way, we see that the time between the circle and the present moment, that is, yeah, I should put it differently. So the time between the black circle and the black triangle in this example is right censored. It's right censored by the end of the observation period, by the present time. So the only thing we can say is that this development time of the claim is going to be larger than what we observed so far at the present moment, but we don't know how much larger. So that's another example of right censoring. If you look at the reporting process, there things are a little bit more subtle. If you look at the reporting process, then this claim, this one, this is a claim that has been reported at the present moment. How do I know that? Because the black circle is taking place before the present moment. This claim has also been reported to the insurance company, because the black circle is taking place before the present moment. But this guy, and also this guy, these are claims of which we're not yet aware of, because their reporting will take place in the future, even though the corresponding accident already took place in the past. Yeah. So what we're going to say is that we only observe those claims for which the delay between the occurrence of the accident and the reporting of the claim is smaller than the time that elapses between the occurrence of the claim and the present moment. Yeah, because if you look at the occurrence of the claim and the present moment, that's the maximal possible delay in reporting a claim that you can allow for the claim to be observable in your data, for the claim to be reported to the insurance company. So this is an example, and it's quite subtle, it's an example of right truncation. Because you only have those claims reported in your databases for which the reporting delay, the time between the accident and the reporting, for which the reporting delay is smaller than a specific value, and that value is the time between the accident and the present moment. Yeah? So there is an example of right truncation in this picture as well. You may wonder what these two acronyms refer to. RBNS is for reported but not settled, and IBNR is for incurred but not reported. Yeah. So here, I want to bring you to the essentials. So what you should know about censoring and truncation. So with censoring, we have some information about the variable of interest, but we don't know the variable itself. And with truncation, we have some individuals or some objects of a subset of the population which don't appear in the sample. Now, if you look back at the kind of policy modifications that we've been discussing, deductibles, policy limits, which of, if I ask you, think about a deductible and think about a policy limit, then the deductible, is it an example of truncation or censoring? And the policy limit, is it an example of truncation or censoring? So for censoring, that would be an application, or sorry, the limit indeed would be an example of censoring, because you pay part of the actual claim amount, but you don't pay the full amount. And with the deductible, that's an example of truncation indeed, because you will only see those losses that are larger than your deductible. Yeah, that was the kind of link that I was thinking of. So with right censoring, we observe the smaller of the true variable and the censoring variable, where in our example, for instance, with the disability, the true variable would be the time from the beginning of the disability until recovery, or the time from the end of the waiting period to the recovery. And the censoring variable would be the time from the end of the waiting period until the present moment, until observation. And examples of right censoring that we frequently encounter in a risk modeling context are the following one. I think I mentioned all of these before. Yeah. A little bit of notation. It's not so important yet, but it will become more important towards the end of this course. So if you think about right truncation, you say Y is the variable of interest. C is our censoring variable. So for example, it's the time from the end of the waiting periods until the present moment. And Y is the time between the end of the waiting period and the recovery. So what we observe then is the minimum of Y and C. And we can also observe an indicator variable, delta, that tells me is the Y larger than or equal to C or not. So if this delta is equal to 1, you would say that the observation is right censored. If the delta is equal to 0, then the observation is observed in full and is not right censored. Yeah, so that's what this right censoring is about. So you sort of see a minimum of the actual variable that you're interested in, and a kind of limited censored version of this variable. So you see part of what you're actually interested in, you don't see it in full. So that's a very important difference with censoring. Observations are available in the study, but in limited form. With truncation, we have missing data. We just don't observe certain data points in our data sample. Yeah. So that's what I wanted to add, especially for those who have not been discussing this censoring and truncation before. So I think these messages are very important. Censoring, you have part of the observation, but you don't have it in full. With truncation, you lose certain observations because, for instance, they do not overshoot a certain threshold.